Hello everybody, welcome back to Math 245. We are still talking about solving systems of linear equations. This is a different method. This is called solving linear equations by substitution. So let's go ahead and jump right in. So last lesson we talked about how to solve systems of linear equations by graphing. And again, this is another method, and it allows us to basically plug in one of the equations into the other in order to solve for our solution. So here we have a pretty nice step-by-step guide as to how to solve systems of linear equations using substitution. Our first step is to ensure that one of our equations is already solved for the other variable. So we always want to make sure that we have either x equals or y equals, and if this is not the case, then we can solve for either variable before we begin this process of substitution. Then we substitute that expression that we found in step 1 into the other equation for that variable. So if we have y equals in our original equation, then we would substitute that expression in for y and vice versa for x. Then I can solve for the remaining variable pretty easily. I take that solution and plug it into the original equation to find the other variable, and then I check my answer at the end. So this may seem like a lot of steps, but it's pretty straightforward once we do an example. So let's go ahead and try out example 1. So I want to solve the following system of linear equations by using the substitution method. So our first step is to ensure that one of our equations is already solved for the other variable. And that is true here, right? Here, my first equation looks like x equals negative 4y minus 6. So step 1 is already taken care of. We're good to go. Then I want to substitute this equation into the other equation. So basically, since this is x equals, I'm going to be plugging this expression right here in for x in my second variable. So this is going to give me 1/2, but instead of x, because I know that x is equal to negative 4y minus 6, I'm going to replace this x with the expression above, negative 4y minus 6, and then I have the rest of the equation, which is plus 7y is equal to negative 13. So this was step 2 in the steps above. My third step is to solve this equation for one of the variables now. In this case, I'm going to be solving it for y. So I first need to distribute this 1/2 to both of the terms on the inside of this parenthesis. So I have 1/2 times negative 4y. That gives me negative 2y. And then I have 1/2 times negative 6, which gives me negative 3. Plus 7y is equal to negative 13. I can combine this negative 2y with this 7y to give me 5y minus 3 is equal to negative 13. In order to solve for y, I am now going to add 3 to both sides, which gives me 5y is equal to negative 10. And finally, I divide both sides by 5 to get y equals negative 2. So this was step 3. I solved for y by consolidating like terms and isolating my variable y. My next step is that I take this part of the solution, y is equal to negative 2, and I plug it back into one of my original equations in order to solve for x. Right, this is only half of the solution. I now need to solve for x. So I'm going to plug it into any equation, either one of the original equations that I would like. So I'm going to plug it into the first equation. So I have x equals negative 4y minus 6. Well, I know that y is equal to negative 2. That's what I just solved for. So I have x equals negative 4 times negative 2 minus 6. This gives me negative 4 times negative 2 is 8 minus 6. So I get x is equal to 2. This was step 4 of the steps above. My last step is to check my solution. So putting these 2 points together, I have the solution x is equal to 2, y is equal to -2. So this is my proposed solution. But before I call this good, I need to check my solution by plugging in this point into both of my original equations. So let's go ahead and do this. I have x equals -4y minus 6. Plugging in our point 2, comma -2 into this equation gives me 2 is equal to -4 times y, which is -2 minus 6. This gives me 2 equals 8 minus 6, which is good. And then I need to plug in this point into the other equation. So I have 1/2 x plus 7y equals -13. If I plug in the point 2, comma -2, this gives me 1/2 times 2 plus 7 times -2 equals -13. Well, let's see, 1/2 times 2 is 1. 7 times -2 is -14, is equal to -13. So this is true. We are done checking our solutions. This was step 5. That means this solution to -2 is the right one. So this is how we solve these systems of linear equations by substitution. So just to make sure that you understand this, what I would like for you to do now is pause this video and try to solve the next example by yourself. You will have to solve the first equation either for x or y, but after that it will be the same process as the one that we just did. So go ahead and pause this and try the next example on your own. All right, hopefully you took a couple of minutes to try this example by yourself. Our first step is to make sure that I have either x or y solved for in one of my equations. Here I don't, right? The first equation says -x plus y is equal to -5. So I need to solve this for either x or y, and I could solve for either one, but I'm going to solve for y. So I have -x plus y equals -5. In order to solve for y, I'm going to be adding x to both sides of the equation to give me y equals x minus 5. So this was step 1 in that 5-step process. Our next step is to plug in this expression into the second expression wherever I see a y. So this gives me 2x minus 5y equals 1, but instead of this y here, I'm going to substitute this expression right here. This gives me 2x minus 5 times x minus 5 is equal to 1. Now I'm going to be distributing this -5 to both of these terms inside the parentheses. So I get 2x minus 5x, and then I have -5 times -5, which is plus 25, equals 1. Now I can combine like terms, so I can combine this 2x with this -5x, and I get -3x is equal to 25, plus 25 is equal to 1. Now I can subtract 25 from both sides, which gives me -3x equals -24. Dividing both sides by -3 gives me x is equal to 8. So my second step was plugging in my expression y equals x minus 5 into my original equation. That was step 2. And then step 3 was solving for one of my variables. I solved for x, and I got x equals 8. Now I need to plug in this half of the solution into either one of the original equations to solve for y. I'm going to plug it into the second one, just to make sure it works. So I'm now going to be plugging in x equals 8 into 2x minus 5y equals 1. This gives me 2 times 8 minus 5y equals 1. Oh, sorry, 1. I get 16 minus 5y equals 1. I can subtract 16 from both sides. Come back up here. This gives me negative 5y equals 1 minus 16 is negative 15. Dividing both sides by negative 5 gives me y equals 3. So combining x equals 8 and y equals 3 gives me my solution 8, 3. This was step 4 in this process, solving for the other variable. And the last thing that I need to do is check my answers. So I'm going to be plugging in my solution into both of the original equations. So my first one was negative x plus y equals negative 5. This gives me negative 8 plus 3 equals negative 5. And this is true. My other one was 2x minus 5y equals 1. This gives me 2 times 8 minus 5 times 3 equals 1, or 16 minus 15 equals 1. Also true. So this is how we solve systems of linear equations by substitution. Because we're exploring lots of different methods as to how to solve systems of linear equations, both lessons today explored different ways to do this. Either substitution or the graphing method we did in the previous lesson works. However, sometimes one of the methods is easier than the other method. So that's why we are looking at both of these. But either one of these methods will work any of the time. As always, please let me know if you have any questions, and I hope to chat with you soon.